Student, today we will learn the chapter Permutation. Student, what do you mean by permutations? In this chapter, it's very important. First, you have to know the meaning of this word permutations. This will be described. I will describe this by an examples. Let there are Ramesh, Mohan and so on. Three persons want to be keep in a line, and photo you have to take a photo of Ramesh, Mohan and so on. So how you can find out the photograph? They can stand this way, Ramesh, Mohan, so on, Mohan, Ramesh, so on, Mohan, Ramesh and so on. This way they are the different photographs. So you have to calculate how many photographs you can find out in a line. So student, if we want to be know by calculations method or by any method number of photograph in a different line. So the number of lines, if you count it, then that is the number of ways they can keep in a line, or that is also known as the permutation. Permutation means number of ways in a line. Okay, it may be in a circle, Ramesh, Mohan, so on. So how many they can number of ways in a circular. So I will describe it. Permutations are two type. Permutations are two type. Number one is line permutations and number two is circular permutation. So student, first I will describe you about this permutation, line permutations. Okay student? So now I want to be say, if you want to be take a photograph of three person ABC, then how you can find number of ways or number of permutations, that is the line permutations. First I will describe about the line permutations, then after this I will describe it about the circular permutation separately. Okay students? So now we have to calculate, or we have to draw any diagram, so we can learn the number of ways of photographs of these three persons ABC. Now let A stand first in a line. Okay, then B and C have to choose to stand in the second place. If then the second place B or C will be choice, if B stand, then C goes to third place. If B stand, then if C stand in second place, then B goes to at the third place. Okay. So student, at the third place, you can see here, at the first place if A stands, then B or C will be rushed to at the second place. If B stands second place, then C have to be go toward the third place, and if C stand on second place, then B have to go to the third place. Let if B stand on the first place, then what happened? A and C have to be rushed to the second place, but A stand to second place, then C have to go to the third place. If C has to second place, then A have to go to the third place. Now if C stand on the first place, what happened? You can assume this. Okay, if C stand on the first place, then A and B will have to be rushed to the second place. If A on the second place, then B will be on the third place. If B on the second place, then A will be on the third place. So you can see, is there any other method to standing on this photograph? So you can see that there are how many ways to keep it, to count the photographs. Number 1 photograph, A, B, C. Okay, A, B, C. This is the first photograph. Okay, now similarly it will be the second photograph, A, C, B. A, C, B. Similarly you can see here and see here and see here and see here. The next photographs are B, A, C and B, C, A and C, A, B and C, B, A. Now how many photographs? 1, 2, 3, 4, 5, 6 photographs. So we can say number of different type of photograph if 3 persons standing in a line and they want to keep a photograph in a line, and this is known as the number of ways in a line, or this is the permutations. The number of permutations are 6. Total number of permutations are 6, and this method is known as tree method. Number of ways or permutation are here 6. In this example we can see number of permutation are 6. Okay students, now let only 3 students again here, A, B, C, and 2 persons want to take the photograph. A stand here, then B or C, then 2 persons are only take the photograph. If B stands here, then A and C. If C stands here, then A and B. So you can say there are AB, AC, BA, BC, CA, CB. If on 3 persons are there and only 2 persons want to take in a line, and we have to take a photo, then there are method are 6. Okay, so if only 1 person want to be in a line, then only A, B and C, there are 3 ways. So this method is known as tree method. This is known as tree method. Okay, but student, it's very difficult to draw the tree method, so sometimes we have to use the formula. Okay, so what is the formula? You can see this way. If there are 3 persons and all 3 persons want to take a photograph, first place can be covered by A, B, C by 3 ways, and the second place can be covered by 2 ways. Okay, if A is here, then B and C are here. If B is here, then C and A are here. If C is here, then A and B are here. And third place can be covered by only 1 ways. So if we multiply this with this one, so we can find out the total number of ways, that is 6. It is the multiplication or product by product. Okay, so by product theorem we can find number of ways or permutations. Okay, so student, this is also very difficult. If we want to take a new formula, and then what will be the new formula? In 3 different objects, by 3 different objects, if we want to fill 3 places or 2 or 1. We cannot fill the more than 3 places. Okay, so we can write here 3p3 or 3p2 or 3p1. P means permutations. From 3 objects we are filling the 3 places. From 3 objects we are filling the 2 places. From 3 objects we are filling the 3 places in the previous examples. Okay, so we can say NPR. From n different objects we are filling R places in a line. From n different objects we are filling R places. Okay, so we can say R is less than equal than n. R cannot be more than n. Okay, R less than equal than n. This is the formula for permutation. And now what is the meaning of this? We can write it this way. Now if we write here 3 into 2 into 1, we can write in it this way, this using this symbol or using this symbol. The meaning of this 3 into 2 into 1 is this one, and this symbol or this symbol is known as factorial. This means 3 into 2 into 1. If we write here 3, means if we write n, it means n minus 1, n minus 2, n minus 3, dash 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 up to 4 into 3 into 2 into 1. So factorial n here is factorial 3, means 3 into 2 into 1. Okay, so if it is 3 minus 1, 2 up to 1, 3 to 1. If it is 10, 9, 8, 7 and so on up to 4, 3 to 1. Okay, this is the symbol of factorial. Now we can write n meaning of NPR, that is the factorial n upon factorial n minus r. And we can say here also n minus 1, n minus 2. If it is n minus r, we can write up to the n minus r minus 1. If it is we can write this way also. Now 3p3, it means factorial 3 upon factorial 3 minus 3, factorial 3 upon factorial 0. Okay, we can write 3 into 2 into 1. Factorial 0 is 1. This I will prove. Okay, so it is 6. Now 3p2, we can write factorial 3 upon factorial 3 minus 2. 3 into 2 into 1 upon factorial 1 equal to 3 into 2 into 1 upon 1, it is equal to 6. 3p1 factorial 3 upon factorial 3 minus 1 equal to factorial 3 upon factorial 2, that is 3 into 2 into 1 upon 2 into 1, it is equal to 3. Okay, student. And now we can write also this way 3p3. So there are 3 factors, 3 minus 1 and less than 1, 3 minus 1, 3 minus 2, 3 here 2 is less than 1, r minus 1. In the previous example, I have already explained that this is, if it is r, n minus r, it is n minus r minus 1. Okay, right? So we can say 3 into 2 into 1. Now 3p2, we can take only 2 factor. 3p1, we can only 3. Okay, so this way we can solve it, right, students? Now I will like to say that I have already explained the meaning of NPR. From n different objects we are taking the n places. We can write n minus 1, n minus 2 dash 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 n minus r minus 1. You can say, if here is r, there are factor 1, 2, 3, 4, the r factor. Here is r minus 1, it is n minus 0. So these are the r factor. Okay, students. Now, in the factorial r is always a positive integer. It is a positive integer. Okay, and it is also 0, but it is not the negative. Positive integers, or we can say it is whole number. R equal to whole number. Okay, so r is never negative, or r is never in fraction, right students? R is in never negative and r is never in right fraction. If r is negative or r is in fraction, okay, that is value is 0. Okay, this we will prove later on. So student, if we want to be right here, NPR equal to factorial n upon factorial n minus r. Okay, let r equal to n, then we can say npn equal to factorial n upon factorial n minus n. So we can write here factorial n upon factorial 0, right? And this npn means taking n different object from, we have to fill the n places. So we can write here n minus 1, n minus 2, dash dash dash, 4 into 3 into 2 into 1. And we can write also this factorial n. So we can say the value of factorial 0 is factorial n upon factorial n is equal to 1. So what we have to prove? We have to prove that factorial 0 is 1. Okay student? So factorial 0 equal to 1. If want to we prove the negative of factorial and in fraction of the factorial is 0, you should be study the binomial theorem chapter, binomial theorem, as I have already explained that values in the binomial theorem chapters you can see. Okay, in an index. So I want to go to the next term, that is, if we take an example that here is a let here is a Lucknow and here is a Delhi, here is a Bombay, and you can go Lucknow to Delhi by these 3 ways and Delhi to Bombay by these 3 ways. So how many ways to go from Lucknow to Bombay? Can you calculate? This one is 1 and this one is 2 and this one is 3, and from this one is 1, this one is 2, this one is 3, and this one is 1, and this one is 2, and this one is 3. So total ways are 3 into 3 equal to 9 object. Okay, 9 ways. So you can go. The permutations are 9 ways from Lucknow to Bombay. In this figure, number of permutation or number of ways we can say that is the 9 ways. Okay, students. Let there are two persons A and B and they want to be sit here. Here are 6 places. 1, 2, 3, 1, 2, 3, 4, 5 and this one is 6. So A will be occupy anywhere. How many ways? 6 ways. Okay. And if B want to be occupy, A can be sit anywhere, then B have to choose the 5 ways. So total ways are 6 into 5 equal to 30 ways. You can find the photograph of this, that is the 30 ways. So this way, by calculations of tree method or by calculation this way, you can find out the permutations. Okay, sometimes you use the theory, sometimes you can use the formula. Okay, students. Now I want to describe this some questions according to this. Okay, and before calculating some questions, I want to explain some more formula. What is the meaning of NPR? You have already understand. And if we want to be from n different object, we will never take one object. So we have to left the one object, then we have to fill by this object R places. Okay. And now if we want to be take one object always, then you can find out the from R places. You can by R ways and left places you have to find out the fill up the R minus 1 places. So what is the meaning of this? That factorial n upon factorial n minus R from n object fill R places. Okay, and here one object is never taken, then fill R places. So factorial n minus 1 upon factorial n minus 1 minus R. Okay, one object is always taken. Okay, one object is always taken and it can be by R ways. So one object is always taken, it can be taken by R ways. Total number ways are R into n minus 1 P R minus 1 R into n minus 1 upon n minus 1 minus R minus 1. Okay, student. Now we can see a particular formula, that is NPR is equal to n minus 1 PR plus R into n minus 1 PR minus 1. So now using RHS we can calculate this. Factorial n minus 1 upon n minus 1 minus R plus R into factorial n minus 1 upon factorial n minus 1 minus R minus 1. Okay, student, we can write here n minus 1 upon factorial n minus 1 minus R, and this is n minus 1 minus minus plus 1, so it is left n minus R. Now you can see it is n minus R is greater than n minus 1 minus R. So we can write this one step n minus r outside, and we can write n minus r minus 1. If it is let factorial 5, it is 5, it is factorial 4. Okay. So student, now we can take the common these two steps. What is the left? N minus 1 upon factorial n minus 1 minus r. We have take the common. What is left? 1 plus n minus factorial r is common, and this one is common, r upon n minus r. So we left here r upon n minus r. So we can say, taking LCM here, what we can write here, this n minus r can be right here, and this is n, and this n can be written with this factorial n, and this can be written factorial n minus r, and it is npr. So it is LHS. So this can be proved easily. Okay student. Now student, you can write factorial 6 upon factorial 5. How you can weigh 6 into factorial 5? It means 5 into 4 into 3 into 1 upon factorial 5. So you can go through this way easily. Don't write 6, 5, 4, 3, 2, 1 and 5, 4, 3, 2, 1 then cancel out. Okay. Using this you can solve the equations. And another example that you have to solve factorial 10 plus factorial 9. You can write 10 into factorial 9 plus factorial 9. Then first take the common factorial 9. Then 10 plus 1. You can write factorial 9 plus into 11. So this way you can, using the factorial formula, subtracting, adding or multiplication, you can solve the so many questions. Okay student. So in this exam we have learned already that meaning of the permutations. That is, the first we have studied the line permutations by tree method, okay, by formula npr, and the meaning of n minus 1 pr minus 1, and the meaning of one thing is always taken, that is r n minus 1 pr minus 1, and the relation between them. Now we will do some special questions on this topic of the line permutation. So now we are going to do some questions. Later we will do some questions this way. From A, B, C, D, find number of ways or line permutation to find out word meaningful or meaningless, meaningful or meaningless. When you are going to be number of ways, okay, that is a meaningful or meaningless, you should not think about this. You have to find out the only number of ways. Okay. So using these 4 letters A, B, C, D, okay, find number of ways. First, taking all letter, so we can say here 4p4, that is the factorial 4, equal to 4 into 3 into 2 into 1, that is 24. Okay. Using tree method you can count this way also, taking A then B, C, D, taking B then CACD and weight. Using taking method, tree method, you can also find out the total 24. And if you want to be multiplication theorem, you don't want to be find the formula, then you can write first place can be filled by 4 ways, second place can be filled by 3 ways, and third place can be filled by 2 ways, and fourth place can be filled by 1 ways. It is the place, it is the ways. Okay. So by this 4 into 3 into 2 into 1, we can find 24 ways. Okay, this way you can also describe it. First place can be filled by 4 ways, second place can be filled by 3 ways, and third place can be filled by 2 ways, and fourth place can be filled by 1 ways. This is the theory and this is the formula. Any questions you can solve anyways, but you have to learn the multiplication theorem also and formula also. So now second question. Taking 3 letters, so you can find out 4p 3, 4 into 3 into 2, that is also 24. Okay. Third, taking 2 letters, so that is 4p 2, that is 4 into 3, 12 ways. Permutations are 12 ways. Now next question is taking 1 letter, that is 4p1 is equal to 4. Okay. So now the next question is taking AB together. Taking AB together, first we put in a box that they are together, then C and D. We have to think here 3 letters. So we can write here 3 into 2 into 1 ways. Okay, but AB can change in a box by 2 ways, AB and BA. So we can multiply it by this. So total ways are 12 ways. Okay, taking AB together, let AB in a box, they are together, they cannot be separated, but we can write in the box AB or BA by 2 ways. So there are 2 methods, 3 into 2 into 1, total ways by multiplication theorem are 12 ways. Okay, and now 6, AB never together. So in the first examples, in the first questions, we have learned 4p4, that is 24, in which all methods are come, they are together and they are total method. So AB never together are 4p4 minus 12, that is 24 minus 12, that is 12 ways. Okay, that is 24 all method and they are together method, and this is never together method. So total method minus all together method are 24 minus 12 equal to 12 ways. This understand. If you want to find the never together, first you have to find this together, and first question also you have to find out. Okay students. Now next question is start with A, then put A by 1 ways and other 3 place you have to fill by other 3 numbers, that is 3p3. Okay, so that is equal to 3 ways. So total ways are 1 into 3 equal to 3 ways. Okay. Next, AND with A, AND with D. Then you can fill AND ways with D. Then other 3 places you have to fill by 3 ways. So total ways are 3 into 1 equal to 3 ways. Okay. Start with A and end with D. To fix here A and end here D, and between these 2 places you have to fill by other 2 letters. The total ways are 1 into 2 into 1 equal to 2 ways. Okay. Either start or end by A and D. So these are 2 ways, start or end by A, D, D, A. So 2 places you have to fill by 2 ways, and these 2 places you have to fill by 2 ways. Total ways are 2 into 2 equal to 4 ways. Either start or end by A and D. So this way, so many questions where you can use the multiplication theorem. Okay, here 2p2 means these are 2p2. So you can use also formula also. But formula and theory, your multiplication theorem, both you have to take together. Okay, students. Now, next we want to be describe more questions. Okay, so in the next part we will describe some more questions in the next video, that is the permutation part 2. So go through the permutation part 2 video. Okay, then you will go to the next questions for continuation. Okay, students, we stop this video and next you go to the next video. Okay, thank you.